In this example, we're given some information about a couple of angles, angle A and angle B, that we know reside each in the fourth quadrant. And we would like to find then the tangent of the sum of these two angles. So if you'd like to try it first, pause the video and do so, and then come on back and we can work it together. Alright, so the tangent of A plus B. Well, I know I have a nice sum identity that I can use for tangent, but before we get that far, we need to draw a couple of reference triangles in the fourth quadrant, one for angle A and one for angle B. So let's go ahead and draw a couple of fourth quadrants here. And so we see the x-axis and the y-axis in both cases. And drawing these angles down into the fourth quadrant, well, will look something like this. And so this guy will be angle A, and this guy will be angle B. So anytime that we're talking about A, it's going to be this reference triangle, and anytime we're talking about B, we'll use this reference triangle. And so, of course, they're not triangles yet because we need to draw from the terminal side of this angle to the x-axis. So there's a nice right triangle, and then there's a nice right triangle. All right, so let's go ahead and put in some values for these triangles so we can use them. Cosecant of angle A, so we're going to use this triangle first. And cosecant, we know, is a reciprocal function for sine. And sine is opposite over hypotenuse. So this guy will be hypotenuse over opposite. Okay, so that means 3 radical 6 will be our hypotenuse, and the opposite side will be 2. And of course, this 2 is coming down parallel to this y-axis, so he'll be a negative 2. And now we can go ahead and use our Pythagorean theorem to find the value or the length of that third side, which is going to be this other leg. We'll call it A. So A squared plus, well, B squared is the square of this leg, so 4 equals the square of the hypotenuse. So 3 radical 6 squared will be 3 times 3 times 6, because the square root of 6 squared will just be 6. So 3 times 3 is 9, times 6 is 54. And so A squared then is 50 when I subtract 4 from both sides. And taking the square root then, A is going to be, it looks like 5 radical 2. So we'll go ahead and put that value in, and it'll be 5 radical 2. And he's positive because we're moving to the right down this x-axis. Okay, let's do this second triangle now. So we have the cosine of angle B, and yeah, here's our angle B. So cosine is adjacent over hypotenuse, so this will be adjacent over hypotenuse. And this one's much easier to do. We can do a squared plus b squared equals c squared. Radical 7 squared is just 7, and 4 squared is 16, so 16 minus 7 is 9, and the square root of that will be 3. So here's our 3, and of course that'll be negative because we're coming downward parallel to the y-axis there. So looking at the problem in its totality, here we are. So we have these two angles, A and B. We know we're in the fourth quadrant, and here are our reference triangles that we built. So now let's go ahead and find the tangent of the sum of these two angles. So we have a nice identity that we can use. So let's go ahead and write this identity down. So the tangent of A plus B equals. So what this is going to be is a fraction. It'll be the tangent of A plus the tangent of B, all divided by 1 minus, and it'll be the product of these, tangent of A times the tangent of B. So really it looks like we just need two values, the tangent of A and the tangent of B, and we can go ahead and plug them in and do our business. Okay, well, this is going to be kind of a fun one to do. Radicals everywhere, and it's going to be maybe a little tedious work, but it'll be okay. So tangent of A. Okay, tangent is opposite over adjacent, so it's opposite, so negative 2 over adjacent, 5 radical 2. So negative 2 over 5 radical 2, that's our tangent of A, plus our tangent of B. So tangent again, opposite over adjacent, so negative 3 over radical 7. So negative 3 over radical 7. That's the sum of those two over, and it's going to be 1 minus, and now we're going to multiply these two together. So I'm just going to go ahead and copy these down, but instead of adding like we did in the numerator, we're going to be multiplying. Okay, so this is what this looks like. So in the numerator here, let's get common denominators. And so I can do so, it looks like it's going to be 5 radical 14, because radical 2 times radical 7. So 5 radical 14. So when we multiply this one by radical 7, it'll be negative 2 radical 7. And we'll multiply this one by 5 radical 2, so it'll be minus 15 radical 2. So that's what that'll look like. And down on the denominator, let's multiply first. So a negative times a negative will be a positive. So it'll be 1 minus 2 times 3 is 6 over, that same denominator. Okay. So let's go ahead and change this 1 into a 5 radical 14 over 5 radical 14. So ultimately it'll be 5 radical 14 minus 6 over that common denominator of 5 radical 14. And the numerator up there won't change, so we'll just bring everything down and keep it just the way that it was. So we have a nice complex fraction, and remember with complex fractions we're really doing division here, and division by a fraction means multiply by the reciprocal, so we'll flip this guy over. So 5 radical 14 over, and then of course we have that 5 radical 14 minus 6. Okay, so this is probably the best part of the whole problem, is that these cancel and it only gets ugly from here. Okay, so we have our numerator, negative 2 radical 7 minus 15 radical 2, all over 5 radical 14 minus 6. If you're one of those people who wants to leave it just like that, more power to you. This is beautiful. And this is the answer, and this is great. If, however, the radical in the denominator bothers you, and you would like to rationalize this, let's go ahead and do so. And so this process, we're going to multiply the top and bottom by the conjugate of the denominator. So we'll multiply by 5 radical 14 plus 6. Okay, so I'll put parentheses around everything, and here we go. All right, so there's our value, and that wasn't too bad. So we were able to rationalize that denominator and simplify it a bit, and we're left with this value here, and the denominator, of course, is rationalized. So this value represents the tangent of the sum of these two angles, A plus B, and these angles were given to us by these reference triangles, which we were able to build by this initial information with these trig functions and knowing that this was in the fourth quadrant.